Okay, so we're going to solve trig equations by factoring. This is lesson 5-1. Okay, the first thing you have to do in factoring is you want one side to equal 0. So we already have that here. And then we're going to look, how can we factor 2 sine squared x minus 3 sine x plus 1? Okay, just want to remind you that back in Algebra 1, Algebra 2, you might have had something that looked like this. Right? And so instead of sine squared x, it was just x squared. Okay, and we told you guys if you take the first times the last, right, and multiply them together after factoring out the GCF, of course, which this doesn't have, okay, and then you'd say 2 times 1, you add them together to get 3, but you need it to be negative 3, so you would have had negative 2, negative 1. Okay, so we're going to do similarly here. We're going to have 2 sine squared x, then minus 2 sine x minus sine x plus 1 equals 0. Okay, and then we look here, and they both have a 2 sine x, leaving sine x minus 1. And then here we have minus. They only have 1 in common, so that leaves us also with sine x minus 1. And then we know that sine x minus 1 times 2 sine x minus 1 equals 0. Then you take each factor and set it equal to 0. And you solve for x. So sine x would equal 1. And here 2 sine x minus 1 equals 0. So 2 sine x equals 1, and therefore sine x equals 1/2. But we don't want sine x, we want x. This is when you use your unit circle, your special relationships, okay? And you go around and you know that sine x equals 1/2 at pi over 6. We're at pi over 6 instead of 30 because we're between 0 and 2 pi according to this, okay? And that's the first time that sine x equals 1/2. It would also equal 1/2 over here at 5 pi over 6. Okay, and that's the only two places it's 1/2. Then sine x equals 1. Well, that's going to happen when y is 1, which only happens at pi over 2. Okay, so that's the other location. So my answer here is x equals pi over 6, pi over 2, and 5 pi over 6. Okay, and because we're factoring and we have squares, we sometimes get extraneous roots, so you want to go back and check, will all of these work? Generally speaking, they're all going to work unless you get into where you have cotangents, tangents, secants, and cosecants, where there's a possibility that the function is undefined at that point. Okay, all right. Okay, let's look at the next one. We're not equal to 0, so we want to subtract. We want to subtract square root of 2 cosine x from both sides. Okay, so we have 2 sine x cosine x minus square root of 2 cosine x equals 0. Now we look for common GCF, right? They both have cosine x, so we're going to factor that out. And we're left with 2 sine x minus the square root of 2. Okay. Won't factor anymore, so we break them apart. We have cosine x equals 0 and 2 sine x minus the square root of 2 equals 0. Okay, so where does cosine x equal 0? Okay, going back to our unit circle. Cosine x equals 0 where x is 0, which happens at pi over 2 and 3 pi over 2. Okay, so we would say here x is pi over 2 and 3 pi over 2. Okay, solving here, we'd have 2 sine x equals square root of 2. So sine x equals square root of 2 over 2. Okay, going around our unit circle, we find that happens at pi over 4 and also at 3 pi over 4. The other pi over 4s, other multiples of pi over 4 are negative, so they wouldn't work. Okay, so we have both these and these as our answers. Okay, so continuing on. Example 3, cosine squared x plus cosine x, 6 cosine x plus 5 equals 0. Okay, so first we want to factor. Just as a suggestion, some people were having a little trouble factoring it is a trinomial. So my suggestion is replace cosine with y. And so you could rewrite this as y squared plus 6y plus 5 equals 0. And then you know that 1 times 5 is 5, so this would, and then 5 times 1 is the only way you're going to get 5. Okay, and then we're adding them together, so we'll get 6. So you could change this to y squared plus 5y plus y plus 5 equals 0. Then you look for your GCF in your two groups. You get y times y plus 5, and you get 1 times y plus 5. Okay, so if we go a step further, they're both y plus 5. That's going to be y plus 5 times y plus 1. So if we come over here to our cosine, and put it in instead of y, we would have, that would be cosine x plus 5 times cosine x plus 1. And then we would break it apart. Cosine x plus 5 equals 0. Cosine x plus 1 equals 0. So cosine x equals negative 5. Cosine x equals negative 1. Okay, so where does cosine equal negative 5? Well, it doesn't, right? Because remember, our range for cosine is from negative 1 to 1. So this never happens. Okay, where is cosine x negative 1? Okay, so if we look on our unit circle, right, cosine x is going to be negative 1 wherever x is negative 1. Or the value of x is negative 1. So that happens at pi. So x equals pi is the only solution to this equation. Okay, so cotangent squared minus cotangent squared times cosine squared x. All right, so it's already equal to 0. I see that there's a cotangent squared in each one, so I'm going to factor that out. That's going to be my GCF. And I'm left with 1 minus cosine squared. Okay. And so that will further factor to cotangent squared x times 1 plus cosine x times 1 minus cosine x equals 0. Okay, so that's as far as it's going to factor. So I will have cotangent squared x equals 0. And 1 plus cosine x equals 0. And 1 minus cosine x equals 0. Okay, so where does cotangent squared x equal 0? Okay, well, remember cotangent is x over y. So it's going to be where x is actually 0. Okay, and that happens at pi over 2 and 3 pi over 2. Okay, so x is pi over 2 and 3 pi over 2. Okay, so cosine x would equal negative 1, and here cosine x would equal 1. Where does that happen? Well, at pi and 0 and 2 pi. Okay, now on this one we have to take a minute because cotangent has spots where it's undefined, and we've mixed it with cosine, which doesn't have any undefined spots. So we have to check out and see what happens when we replace pi for x. Okay, so if you take cotangent squared of pi, okay, remember pi is over here, it's -1, 0, and cotangent would be x over y. So at this point, that would be -1 over 0, which is undefined. So that's not going to work. Okay, and then over here at 0 and 2 pi, you have 1, 0, and for much the same reason, right, it will be undefined. So those are not going to work for this particular equation. So our only answers are pi over 2 and 3 pi over 2.